Hello everyone. So today is 12th of May and yesterday we had our ISI entrance exam and I'm going to start discussing the solution for the UGB 2025 as I usually do every year. So I'll try to solve all the problems. Yesterday I did not get time, so now I'm trying one by one, and as I solve each of them, I keep on posting the solutions. First of all, like everyone would like to know what would be the cutoff. So as we all know, even in the last year also, many students got into like ISI by doing three subjective questions and 80 to 90 marks in UGA. Okay. And so the thing is that last year question paper was much easier than this. So this year question paper is a little tough, but it's a good question paper. And again, let me tell you that those who are worried about those who have done three problems and you are getting almost 80 to 90 marks in UGA, so you have a very high chance of getting in. And those who have done like more than three problems in the UGB, so you have exceptionally done. You have done exceptionally well. And those who have done again two problems correctly, fully two problems, please don't lose hope, because again, as every year, you know that the big institutions having 5 to 6 experts teaching for ISI, so you you know that they are also not able to solve, like all those group of faculty members together, they are able to solve only one question. Okay, so every year I tell you the same, and every year you see the same thing happening, because they solve the MCQ problems, but they fail in the UGB portion. Okay, and so try to understand that they are teaching and you are the student. So try to understand the difference. So that's why I say that you don't you have to solve 5 to 6. It's not that necessary. So even if you have solved two questions correctly, so that will also do. And if you are getting you in UGA, you are getting 80 to 90 marks. So I think that's good to go. Okay, so don't lose hope. Okay, and yeah, so let's start one by one. So let's start with the first question. So which says that you have a function, a real valued function, which is differentiable, and if dash x mod is less than half for all real x, you have to show that there is some x naught such that f of x naught is equals to x naught. Okay, so that means what? You have to show that the function has a fixed point. Okay. So now what does it mean? That is the function, if you draw the line y equals x and the graph of f of x, so they will be cutting somewhere. Like these two graphs will be cutting somewhere at the point x. Okay. Now try to understand. What if it doesn't? Like what if I contradict the statement? What if I go with the help of contradiction? So I say that no, it doesn't happen. Okay. And I go with the help of contradiction. And so then, like, what can I say? So you must be knowing the fixed point theorem and the intermediate value property. So the very first thing is that even intermediate value property is in your JEE main syllabus. So you must be knowing that. And now here we have like f is differentiable function. So f is then also continuous over the whole of R. And so now since f is continuous, so it should also satisfy the intermediate value property. So now try to think of like this. That is, let's go to the whiteboard and yeah, let's discuss. Okay, so now let's think that. So this is question one. So think that I say that f of x is not equals to x for all x real. Okay, so this is my hypothesis or assumption. That is, let f of x is not equals to x, or we are assuming that f of x is not equals to x for all x real. Okay, so I'm going with the help of contradiction. So that means what? Now that means that first of all, my function f is continuous. So if I take the function g of x, which is f of x minus x, so which we also do, we construct these type of functions while even proving the fixed point theorem as well. So this is a very like normal thing to do. And so now if you look at here, that is, suppose there if there is some like point where the graph of, let's say, f of x, So let's say f of x1 is greater than x1. Okay. So if the graph of f somewhere is above the line y equals x, okay. So that means at some point x1, f of x1 is greater than x1. And also if at some other point x2, so if there exists x1 belonging to real such that f of x1 is greater than x1, and also there exists x2 belonging to real such that f of x2 is less than x2. So that means at some point x2 the graph of the function is below the line y equals x. So then what we know is that by the intermediate value property we know that if you look at g of x1, so g of x1 is nothing but f of x1 minus x1, which is greater than 0, and g of x2, which is f of x2 minus x2, which is strictly less than 0. Okay. So now you see that that means what? G is a continuous function because f is continuous, x is also continuous, y equals x, the function. So that means g of x as a difference of two continuous function. So g of x is also continuous. And now g of x, that means satisfies the intermediate value property. And so we can say that since at some point x1, g, the function g is greater than 0, and at some point x2, the function g is taking value less than 0. So that means there will be some point where the function will be attaining the value 0. So this implies that there exists, so like let's say x3 belonging to R such that, and also like x3 will be between x1 and x2, so such that, sorry, g of x3 will be equal to 0. Okay, and so we get that f of x3 will be equal to x3. So now this is basically contradicting our hypothesis, correct? And so this cannot happen. Fine. So that means if there is no point where like, that means what? Like the function g of x should always be greater than 0 or should always be less than 0, right? Because according to our hypothesis, our gx function is not having any 0. So it's not cutting the x-axis or touching the x-axis, okay? So that means what? So this implies that, and so this is a contradiction, okay? So it's contradicting our hypothesis. That is like f of x is not equals to x for all x that we have taken. And now you would say that, okay, so we are getting a contradiction to our hypothesis. So our hypothesis is wrong. So no. So here what happens is that whatever hypothesis I have taken, so that hypothesis is implying, okay, so that hypothesis is implying that either g of x is always greater than 0 for all x real, and g of x is less than 0 for all x real. So this is what our hypothesis is implying. Okay, why is it implying? The reason is here. That's why I wrote this. Okay, so that the reason is here, that if this does not happen, then our hypothesis is getting contradicted. Okay, so just using the simple intermediate value property. So from here itself I could have written this directly, but yes, a little bit of explanation in between. So now I hope you have understood that either two cases can happen. Either g of x is strictly greater than 0, that means the graph of g of x is strictly above the x-axis, or the graph of g of x is strictly below the x-axis, right? So now let's come to, let's take one of the case. So let's take case 1, where we take that let g of x be greater than 0 for all x real. Okay. So what does that imply? That is f of x is greater than x for all x real, as simple as that. So that means we are saying here that the graph of f of x is always above the graph of y equals x. So that means the graph of f of x is always above the line y equals x. And now let's see. So now let's analyze, okay? So here you would notice that then we can say that at the point 0, f of 0 is strictly greater than 0. No doubt about that, because for all x it's greater than x, okay? And now uh, what we can do here is we also know another property which has been given, that is mod of f dash x is less than or equals to half. So I think strictly less than half. Okay, so it's given strictly less than half. So what we'll do is, let's take g dash x. Okay, we know g of x is f of x minus x. So g dash x will be f dash x minus 1. And so now whatever be the value of f dash x, so we know that that is less than half. So I can say that that value is less than half minus 1. Okay. And so this is less or this is equal to minus half. So that means we got to know that g dash x is less than negative half for all x real. Okay. So now what we'll do is, we will take any point x, and in this interval 0 to x, we see that our function, that is our function g of x, is differentiable, and in open interval 0 to x it's continuous as well. And sorry yeah, I mean in closed 0 to x it's continuous, and in open 0x it's differentiable as well. Okay, and yeah, it's also differentiable at 0 and as well as x. So the main point is that I want to apply the mean value theorem. Okay, so by mean value theorem, but we can say that there exists some theta belonging to 0 to x. So we are taking x to be positive. Okay, so x we are taking it to be greater than 0. So there exists some theta in 0 to x such that g of x minus g of 0 by x minus 0 is equals to g dash uh, theta. Okay, simple mean value theorem. And so we can say from here, that is g of x minus g of 0 is equal to g dash theta times x. And theta, again, it's a real value. And so we know that g dash theta is, I mean, it's, we figured it out, it's less than negative half. So that means this is less than negative x over 2. Okay. So we got to know that the function g of x minus g of 0. So this is always less than x by 2. Okay. Remember that for all x positive, because we took the interval 0 to x. Okay. So for all positive x, this is happening. And now what we can do is that let's say that so I should have written here that yeah, x greater than 0. So anyways, you got the point. Now what I'm going to do is that I'm going to take, let's say, f of x minus x. So basically my idea is to get g of x minus g of 0. That the thing what I got here, g of x minus g of 0. So g of x is nothing but f of x minus x. Okay. And I know that in our case, g of x is strictly greater than 0. So this is strictly greater than 0. And now what I can do that, I need g of x minus g of 0. So g of 0 is nothing but f of 0 minus 0. So basically, if I take f of 0 minus here and do that on the other side as well, so I get this, and which is nothing but g of x minus g of 0. I hope it's very well clear, right? So now you see that we have this relation, and now g of x minus g of 0, we figured it out here, that is it's less than negative x over 2. So let's again I mean use it here as well, that is less than negative x over 2. We can do that. And so what are we getting actually? That is, we are getting, now use this to So from these two, we are basically multiply with the negative sign. So you are getting f of 0 is greater than x over 2. Okay. So f of 0 is greater than x over 2. We got it. Okay. And again, please note down that x has to be positive. Okay. Now, what we will do here is that because yx we need positive here, because we applied the mean value theorem in that interval 0 to x. Okay. So yeah, now let's come down to here. That is what we are going to do here is that is we are going to take x to be 4f0, sorry, 4f0, and let's see. So we can say that f of, and again, try to note that f of 0 is greater than 0 in our case. Okay, so here f of 0 is greater than, strictly greater than 0 in our case, so f of 0 is positive, and so f of 0 into 4 is also positive. Okay, and thus we get that f of, now use this, so we get that f of 0 is greater than f of 4 times f of 0 by 2, and so this comes out to be equal to 2 times f of 0. And so now again you use these two. So what do we get is, like, take f of 0 on the other side, and what you get is that is f of 0 is less than 0. Now here in our case we started with that is f of x is greater than 0 for all x real. So where we got that f of 0 is greater than 0, but here we are getting that f of 0 has to be strictly less than 0. And so this is the contradiction. And so this is not possible. That is g of x is greater than 0 for all x real is not possible, because whatever our hypothesis is, we are getting a contradiction that this case cannot happen. So then what can happen? That is, then there is a possibility that g of x can be less than 0 for all x real. But again, we don't have to go through all that. You can very well now understand that similarly we can also proceed there and show some contradiction and say that that case also cannot happen. So we don't have to go through all these things. So what we'll do is we'll take a shortcut. So what is that shortcut? We will define a function. So what we'll do is we will, again, now here we are assuming that g of x is less than x, g of x is less than 0 for all x real. So that implies that f of x is less than x for all x real. Okay, so now what we can do here is we will be like, let's say we will be redefining our function a little bit here, and let's say that we will take h of x, the function, to be negative of f of negative x. Okay, so now why did I take this function all of a sudden? So first of all, note that, like, f of negative x is less than negative x, just using whatever the case is. And so multiplying by negative sign on both the sides, so negative f of negative negative of f of negative x will be greater than x. Okay, and thus we have that h of x is strictly greater than x. And now you see that the function h of x is also satisfying all the criteria that our f function had. Like, h of x is also differentiable over the whole of R, because h of x is nothing but minus of f of minus x, so you can easily, like, differentiate it. So and also, like, we also have that mod of h of x, which is the condition was on differentiability. So mod of h dash x is equal to mod of f dash of minus x, and which is again by our like, it was given that if dash of x is mod of f dash x is less than half for all x. So whether it's inside x or minus x doesn't matter. So this is again less than half, and so this again h of x is nothing but satisfying all the criteria that f of x did in the first case, in our case 1, and we saw that such a function cannot exist. And so we can here say that h of x cannot exist from case 1. And thus, we have shown that like that both the cases cannot happen. That is, g of x cannot be greater than 0 for all x, and g of x cannot be strictly less than 0 for all x. And so, again, that means somewhere by the intermediate value property, since the function g of x is continuous, so if at some point it's like above the line y equals to x, and at some other point it's below the line y equals to x, so somewhere in the middle it has to cut the line y equals to x by the intermediate value property, as the g of x function is continuous. So again, as you can see, like this was like yes, a little bit. I mean, those who mainly prepare for JEE Mains or JEE Advance, so it's still doable for you all. But again, you might find it sometimes hard to solve subjective problems. But anyways, I think I haven't made the solution too complex. So I have tried to make it as simple as possible for you to understand. And I have used simple results that you should know. And yeah, so I hope like you have got the solution. And again, if so, please don't forget to put a like. And thanks for watching. And see you in the next one where I'll post the next solutions. So yes, that's it for this video. See you in the next one.